Good morning, everyone. We are the last group, the group 7 of CE33, and today we will be talking about the earthquake effects and design of structures. So to start our new topic, I am Noel Macalino together with Ronin, Sheena, CJ, and Devon, my group mates. And these are the subtopics that we will be discussing today. Our introductory topic, the earthquake, damage, danger, and destruction, will be presented by me. So to start our new topic, let's ask ourselves how dangerous is an earthquake? So to answer this question, as we all know, earthquake is a natural phenomenon that happens in our planet that is still very dangerous. And because up until now in our generation, we still do not have such instruments that can know when or where these earthquakes can occur. These earthquakes are very dangerous because it triggers some type of hazards such as safety hazards, environmental hazards, and any other hazards. Also, how do earthquakes cause damage? First we have ground shaking and structural failure. Ground shaking is the vibration of the ground during an earthquake. The shaking triggers other hazards such as liquefaction and landslides. Most earthquake damage results from the seismic waves passing beneath buildings, roads, and other structures. So ground shaking and structural failure, um, we all know that these can cause damage because maraming pwedeng maapektuhan sa pag-shake pa lang nung ground natin, and these can damage not just the buildings but also um, those who are currently residing it or the ones who using it. Next is the surface rupture and ground displacement. The primary earthquake hazard is surface rupture. It can be caused by vertical or horizontal movement on either side of ruptured fault. Ground displacement, which can affect large land areas, can produce severe damage to structures, roads, railways, and pipelines. So pag sinabi naman nating surface rupture, mostly nangyayari naman ito ay sa mga matataas na lugar, tsaka where mas mas natitrigger yung vertical and horizontal shaking ng mga bagay-bagay. Pag sinabi naman nating ground displacement, nakasalalay naman dito yung mga kalsada natin, mga railways and pipelines that can be damaged with such vibrations. Next one is landslides. Alam naman nating ang landslides is very dangerous, lalo na dun sa mga taong nagre-resides sa um, malapit sa mga bundok na ma mga weak na bundok. Nakalimutan ko yung term. Also, we have liquefaction. The shaking from an earthquake can turn loose soil into a liquid during an earthquake. Liquefaction can undermine the foundations and supports of buildings, bridges, pipelines, and roads, causing them to sink into the ground, collapse, or dissolve. Pag sinabi naman nating liquefaction, ito yung paglambot ng lupa or yung foundation ng mga nasa ilalim ng mga buildings, which is very dangerous when it comes to people who are currently using or inside those buildings. Pag lumambot naman syempre yung lupa, alam naman natin na there are tendency na gumuho ito or mag-collapse because yung pinaka-foundation ng building is nag naging weak na. Also, we have tsunamis. An earthquake generated within the Pacific Ocean floor will generate a tsunamis, which are actually a series of very long waves. Large tsunamis, which travel to the ocean floor to the surface, are dangerous to human health, property, and infrastructure. Long-lasting effects of tsunami destruction can be felt beyond the coastline. So alam naman nating tsunami is very also dangerous as we've seen it happen many times in other countries like Japan. So hindi lang ground shaking yung pwedeng mangyari during an earthquake, but it can also trigger the ocean, tas makaapekto din sa coastline and beyond of it. Next, the last one is fires. Earthquake damage facts show fires caused by earthquakes are the second most common hazard. Earthquake fires start when electrical and gas lines are dislodged due to the earth's shaking. Gas is set free as gas lines are broken and a spark will start a firestorm. So fires, it's not the actual term na to say na earthquake can start fires, but it can somewhat cause fires when gas lines or pipelines um, dami will be damaged during the shaking. Siyempre, pag pumutok or nasira or sumirit yung mga lines na yon, mostly gas lines, it has a tendency na masunog, which can be seen in the last photo of this slide. Next one, we have the destruction caused by earthquakes. There are a lot of types of destruction that can be caused by these earthquakes, but we have the three most common destructions by earthquakes. First one, we have surface rupture. The vibrations from an earthquake can lead to ground displacement and surface rupture. The surface rupture can cause other hazards as well as damage to roads and buildings. In this example, the surface rupture has caused large cracks and the collapse of a paved road. This could lead to injuries, loss of life, or impede people from getting home or to work. When we say surface rupture, it mostly the damage or the effect can mostly be seen in our roads pag hindi na ito na dadaanan kasi sira na or damage na. It negatively affects the community, lalo na yung um, mga may work pa after the aftermath of the earthquake. Also, we have landslides. Earthquakes often trigger landslides, which can cause catastrophic damage to homes and towns. This image of a landslide in El Salvador in 2001 shows how destructive landslides can be to people and their homes. Landslides is hindi na naman siguro uncommon sa atin, sa country natin, which is the PH, kasi mas maraming maraming bundok and um, communities, government approved that some communities can reside in these locations. So, mas inaibisuhan ng mga government officials or local authorities ang mga people na nagre-reside sa mga malalapit na bundok, not just when earthquake comes but also in like natural disasters like um bagyo, ganon. Landslides can also happen like anytime or anywhere. The last one is ground failure. Disruptions to the soil generated by these collapses cause transfer of the ground shaking load from grain to grain contacts in the soil layer to the pore water. This transfer of load increases pressure in the pore water, either causing damage to occur or, if drainage is restricted, a sudden buildup of pore water pressure. When the pore water pressure rises to about the pressure caused by the weight of the column of soil, the granular soil layer behaves like a fluid rather than like a solid for a short period. In this condition, deformations can occur easily. So ground failure, as explained by the context, when ground failure occurs, the foundation of the buildings can be damaged, and we can the its foundation by when these the layer of waters broke and then suddenly submerged with the soil layer of the building foundation. It can cause a massive destruction for the foundation of the buildings, kasi syempre ang pinanggagalingan naman nung strength nung mga buildings is of course yung foundation nito sa ilalim. So pag nasira yon, may tendency na it falls or masira na talaga. So next topic. Thank you.
Hello, good morning. My name is Ronin Verona and I'm here to discuss the impact of earthquake on ecosystem and biodiversity. First one is grassland ecosystem. Earthquake is one of the natural disasters that causes ecosystem degradation. Such disturbance may greatly threaten the survival of competition of plant species by increasing mortality and changing habitat quality. The magnitude and frequency of the disturbance of earth of earthquake can affect species diversity and its distribution, which leads to species loss and grassland fitness damage. Some studies showed that earthquakes severely damage the structure and function of grassland ecosystem, which causes biomass decrease, diversity decline, and soil erosion. In the earthquake-stricken regions, the area of grassland, forest, and wetland ecosystem were greatly reduced, with diversity and species abundance decreasing dramatically. In addition, the recovery rate of grassland was the lowest among different vegetation types during the restoration process after the earthquake. It it is of great significance to understand the effect of earthquake on the structure and function of plant community in future vegetation restoration after earthquakes. Next, forest ecosystem. Earthquake are Earthquakes are one such event affecting forests throughout the tectonic, world's tectonically active regions. Seismic shaking can damage trees directly and indirectly. Damage caused by earthquake induced landslide is main source of tree death and injury. Mountain regions landslide include soil movement that uproot, move and bury trees over extensive areas and damage root systems. Soil movement on steep slope can also deposit debris on floodplains that dam streams and submerge forests in valley bottoms. Surface ruptures can fracture roots and split trees. Rock movement include sliding and shear surface through to free-falling rocks that damage individual trees upon impact. Next, next is marine ecosystem. Underwater earthquakes are responsible for tsunamis, and even though it doesn't reach land, it damages population of life under the ocean. Earthquakes disrupt the ocean floor with the movement caused by quakes, which is most destructive during the occurrence of the earthquake. Sea mammals, fish, and especially corals and sea plants have nowhere to go when quake occurs, depending on the severity of it. The ocean floor and land ashore get lifted or drop even lower than it's meant to be. It causes havoc for anything that lives on or above it. It disrupts ecosystem. How do earthquake impact our diversity? Earthquake and other natural hazards generally decrease biodiversity. They can either kill organisms directly or destroy their habitats so that they are no longer able to live in the area where the hazard occurred. Disaster negatively affect the biodiversity of wetlands, forest, and coastal system by causing the spread in invasive species, mass species, mortality, and loss of habitat. In the short in the short term, select ecosystem degradation reduce the availability of forests to sequester carbon, which exab- exas- exacerbates climate change. Next topic.
Good morning, everyone. I'm Sheena Marceliana and I will discuss the effects of earthquake on structures. First is inertia forces in structures. The generation of inertia forces in a structure is one of the seismic influences that detrimentally affect the structure. When an earthquake causes ground shaking, the base of the building would move, but the roof would be at rest. However, since the walls and columns are attached to it, the roof is dragged with the base of the building. So the inertia forces can cause shearing of the structure, which can concentrate stresses on the weak walls or joints in the structure, resulting in failure or perhaps total collapse. More mass means higher inertia force, that is why lighter buildings sustain the earthquake shaking better. Next is effect of deformations in structures. When a building experiences earthquake and ground shaking occurs, the base of the building moves with the ground shaking. However, the roof movement would be different from that of the base of the structures. This difference in the movement creates internal forces in columns which tend to return the column to its original position. So these internal forces are termed stiffness forces. The forces would be higher as the size of columns gets higher. The stiffness force in a column is the column stiffness times the relative displacement between its ends. Next po. Horizontal and vertical shaking. Earthquake cause shaking of the ground in all the three directions X, Y, and Z, and the ground shakes randomly back and forth along each of these axis directions. Commonly, structures are designed to withstand vertical loads. So the vertical shaking due to earthquakes either adds or subtracts vertical loads. Is tackled through safety factors used in the design to support vertical loads. However, horizontal shaking along x and y directions is critical for the performance of the structure since it generates inertia forces and lateral displacement, and hence adequate load transfer path shall be provided to prevent its detrimental influences on the structure. So proper inertia force transfer path can be created through adequate design of floor slab, walls or columns and connections between these structural elements. It is worth mentioning that the walls and columns are critical structural members in transferring the inertial forces. It is demonstrated that masonry walls and thin reinforced concrete columns would create weak points in the inertia force transfer path. And the last one is flow of inertia forces to foundations. Under horizontal shaking of the ground, horizontal inertia forces are generated at level of the mass of the structure, usually situated at the floor levels. These lateral inertia forces are transferred by the floor slab to the walls or columns, to the foundations, and finally to the soil system underneath. So, each of these structural elements, floor, slabs, walls, columns, and foundations, and the connections between them must be designed to safely transfer inertia forces through them. So walls or columns are the most critical elements in transferring the inertia forces. But in traditional construction, floor slabs and beams receive more care and attention during design and construction than walls and columns. Walls are relatively thin and often made of brittle material like masonry. They are poor in carrying horizontal earthquake inertia forces along the direction of their thickness. Next topic po.
Good morning, everyone. I am Christian Cruz, and this is the importance of earthquake-resistant buildings um, based on Tridentia. So, ayun, sabi dito, earthquake daw is isa sa mga natural disasters na matagal nang kinakalaban or hinahanapan ng kahit anong form ng resistance. And sabi din dito sa Tridentia, even if gamitan na ng concrete and steel, ang mga skyscrapers, parang isang challenge pa din daw if merong mag-occur na earthquake. And sabi din nila na na-influence daw na earthquake talaga ang formations and kung paano mag-build ng isang building. And para sa kanila, meron silang ginagamit na dalawang basic type of constructions to observe a building at yun ay yung load-bearing wall structure and frame structure. So, sa load bearing naman, ang sabi nila is the building is created with continuous vertical walls to support the floor slabs at various levels. And while sa frame structure is if continuous vertical walls are functionally inconvenient, a framed structure is used in which isolated vertical posts are joined with horizontal bands to support the structure. So, next po. Next naman is importance of earthquake-resistant buildings based naman to sa inventure. Uh, para naman sa kanila is they use seismic design as an analysis method in constructing a building and para ma-ensure nila ang ground vibrations na nadaan sa kanila and yun yung ginagamit nila para ma-ensure nila yung ground vibrations na nadaan sa building before and after an earthquake. And listed dito yung mga ginagamit nilang tools to compute or record is seismic design like yun nakalagay dyan is ETABS, STAAD Pro, robot, yan, etc. etc. And para din sa kanila, hospitals and educational buildings yung dapat may high relevance ng up to 25 to 50% na parang mas efficient kaysa sa ibang buildings na compared sa mga residential or commercial structure structures since they are used for far more important stuffs sa ating lugar or sa community natin. So, yun. Pa-next po. Pa-next po. Ayan. Next naman is yung important characteristics ng isang building para ma-hold yung armor resist niya ang isang earthquake. So, karamihan naman dito is parang nasa root word na or from the word itself. Like ganito, strength and stiffness and strength. And when designing an earthquake resistant building, safety professionals recommend adequate vertical and lateral stiffness and strength. Ayun. Next is regularity. Pag sinabi naman dito sa regularity, parang sinabi mo na rin yung parang flexibility ng isang building kasi kahit saan mo itulak na direction, parang okay lang yung building. Kung magkakasira man is minimal. Minimal na sira lang. Yung konting cracks or kung ano. And then next is redundancy. Ito naman is para din siyang stiffness and strength eh. Ito naman is yung mga formations pagka may isang nasira or isang nasirang part sa building is nakatayo pa rin yung building or okay pa rin siya. Yung hindi siya guguho. Next po. Next naman is foundations. So ito naman gets na natin yung foundation ng buildings. Next is continuous load path. Ito naman is parang interconnected sa lahat. Sa mga foundations, redundancy or what. Kasi dito sa continuous load paths, ito yung nagtatay ng lahat, yung dinidikit niya lahat. From foundations to walls, hanggang sa roof, lahat. Yun lang po. Next topic.
So hello, I am John David Afrimintilla, and I am going to discuss and introduce to you the design of structure for earthquake resistance building. So over the past few decades, engineers have introduced new designs and building materials to better equip buildings to withstand earthquakes. While buildings are generally equipped to handle vertical forces, from their weight and gravity, they cannot handle side-to-side forces emitted by quakes. These horizontal loads vibrate walls, floor, columns, beams, and the connector that hold them together. The difference in movement between the bottom and top of building exert extreme stress, causing the supporting frame to rupture and the entire structure to collapse. So alam mo naman natin yung structure natin or yung mga buildings natin is malakas lang siya sa vertical forces, which is yung kanyang y-axis, pero mahina siya dun sa x and y axis, which is yung horizontal movement. So kasi kadalasan yung building is horizontal yung movement. So kaya minsan nahihirapan yung ating mga building na i-withstand yung kanyang force na dala-dala. So what is earthquake proofing? To design an earthquake-proof building, engineers need to reinforce the structure and counteract the earthquake forces. Since earthquake releases energy that pushes on buildings from one direction, the strategy is to have buildings push the opposite way. So meaning yung earthquake proofing daw is ika-counteract lang natin yung force na force ng earthquake, which is kahit na hindi masisira yung ating building. Next. So here are some methods used to help buildings withstand earthquake. So yung unang-una is earthquake, create a flexible foundation. So siguro yung iba sa atin is familiar na sa ganitong practice, yung parang nilalagyan ng spring or isolator yung ating yung ating building. Isolated siya from column, from foundation, tsaka yung ating pinaka-structure mismo. So kung makikita niyo yung figure dun sa bandang kanan, yung conventional structure at saka yung isolated structure. So kapag nagkalindol, yung conventional structure is sasabay siya dun sa sa movement ng earthquake. Pero pag itong sa base isolated structure, once na magkaroon ng motion yung ating ground, magiging lang siya, stabilize lang yung kanyang galaw. Next. So, second one is the counter forces with damping. You might be aware that cars have shocks absorber. However, you might not know that engineers also use them for making earthquakes resistant building. Similar to their use in cars, shock absorber reduces the magnitude of shock waves and helps buildings slow down. This is accomplished in two ways: vibrational control devices and pendulum damper. So ito yung parang yung practice naman na ito is parang sabi nga parang sa principle ng ating suspension, parang sa mga sa motor yung parang yung suspension fork niya. So ang 'di ba ang purpose naman is to lessen yung magnitude na yung force na kunyari is malubak yung kalsada. So para ma-lessen yung kaldag na ma-absorb ng rider, so nakakatulong yung yung suspension fork para siya yung mag-absorb ng force from the vibration from the ground. So similar dun sa ito yung naging parang ano ba yun? Ito yung same principle dito sa mga yung parang nilalagyan ng shock yung ating mga building. Hindi ko lang alam kung pinapractice na to dito sa Philippines, pero feeling ko is meron na naman. Hindi lang ganoon laganap. Next. So yung next one naman is yung principle ng pendulum. So the counter forces with damping. So the first method involves placing dampers at each level of a building between a column and beam. So each damper consists of piston head inside a cylinder filled with silicone oil. So ito namang pendulum power na to is common siya sa sa high-rise building. So ano bang relevance nito sa earthquake? So once kasi na mag-move yung ating earthquake, sabihin nating pakaliwa, itong pendulum na to, itong parang bolang malaki, is mag-move siya pa kanan. So nung sa ganon is mas madaling ma-stabilize yung ating building. So hindi siya ganon gagalaw. Sunod dun sa porsa ng lindol. Next. So the next one is shield buildings from vibration. Instead of just counteracting forces, researchers are experimenting with ways building can deflect and reroute the energy from earthquakes altogether. Seismic invisibility cloak. This innovation involves creating a cloak of 100 concentric plastic and concrete rings in burying it at least 3 feet beneath the foundation of the building. As seismic waves enter the rings, they are forced to move through the outer rings for easier travel. As a result, they are essentially channeled away from the buildings and dissipated into the plates in the ground. So kung makikita niyo ating ating figure, yung parang nagkakaroon siya yung ring na to sa paligid ng ating mismong structure. So yung purpose nito is para ma-reroute yung pwersa ng lindol at mapalabas at hindi na makadating doon sa ating structure mismo. So bago tayo mag-construct ng ating structure, parang uunahin natin i-establish yung ating area na pagtatayo ng ating structure. Next. So the next one is to reinforce the building structure. So ibig sabihin lang naman ito is i-design natin yung ating building na mas malakas na makakapag-resist ng pwersa ng lindol. Unang-una is yung shear walls and cross braces. Pangalawa is yung building diaphragms and yung yung principle ng moment resisting frames. Next. So yung shear walls are useful building technology that helps to transfer earthquakes forces made of panels. These walls helps a building to keep shape during movement. Shear walls are often supported by diagonal cross braces. These steel beams have the ability to support compression and tension, which helps to counteract the pressure and push forces back to the foundation. So, alam mo naman natin yung shear wall is, ano siya, aside from parang cladding siya, ano, load bearing din siya. Kaya niya ding magbuhat ng mabibigat na load. So, ang pinaka-purpose dyan nung shear wall sa ating mga structure is para maging kung sakaling gumalaw yung ating building is mananatili siya dun sa kanyang tunay na forma. Next. So yung diaphragm naman is are central parts of building structure consisting of floors of the building, the roof, and the decks placed over them diaphragm. Diaphragm help remove tension from the floor and push force to the vertical structure of the building. Next. So ito yung moment resisting frame. Moment resisting frame is provide more flexibility in building's design. The structure is placed among the joints of the building and allows for the columns and beams to bend while the joints remain rigid. Thus, the building is able to resist the larger forces of an earthquake while allowing designers to move to more freedom to arrange the building element. So, yung principle lang naman ng moment resisting frame is yung i-design natin yung ating frame ng building na rigid siya pero makakasabay sa pwersa ng lindol. Next. So, panglima is earthquake resistant material. So, makakatulong din yung ating makakatulong din yung wais na pagpili ng ating mga structural materials kung sakaling gagawa tayo ng building. So, unang-una is yung steel, pangalawa is wood, tsaka yung futuristic materials. So, kagandahan sa steel is, alam naman natin siya na malakas siya sa tension, then ductile din siya. Sa wood naman, unang-una is lightweight. Then, maganda rin yung kanyang weight to strength ratio. Then, futuristic materials, potential for greater flexibility and shape retention. Next. So, steel and wood, for material to resist stress and vibration, it must have high ductility, which is the ability to undergo large deformations and tension. Modern buildings are often constructed with structural steel, a component that comes in a variety of shape and allows building to bend without breaking. Wood is also a surprising ductile material due to its high strength relative to its lightweight structure. Innovative materials. Scientists and engineers are developing new building materials which even greater shape retention. Innovation like shape memory alloys have the ability to both endure heavy strain and revert to their original shape. Additionally, fiber reinforced plastic wrap made by a variety of polymers can be wrapped around columns and provide up to 38 added strength and ductility. So to conclude my topic that I have discussed, though given na yung ganitong mga practices, pero wala pa rin isang solusyon para magkaroon sa dyan para mapigilan yung pwersa ng lindol. So, itong mga practices na to is nakakatulong lang para ma-resist o para hindi ganon masira yung ating building o hindi ganon niya ma-receive yung lakas o yung magnitude ng lindol. So, I think that would be all. Thank you for listening.